Let's do another calculation where we determine the limiting reactant and calculate the theoretical yield. How many grams of barium sulfate are produced from 200 grams of barium nitrate and 100 grams of sodium sulfate? Given the following balanced equation, what is the limiting reactant? Before we get going here, let's make sure to fill in the coefficients that are not shown. So 1 mole of barium nitrate reacts with 1 mole of sodium sulfate to give 1 mole of barium sulfate and 2 moles of sodium nitrate. The first thing we need to do is calculate the mass of barium sulfate formed from each reactant. So we are given 200 grams of barium nitrate as one of our starting materials and 100 grams of sodium sulfate. So we're going to have to do two separate mass calculations starting from each of those starting material amounts. Before we do our mass calculation, we need the molar mass of barium nitrate which is equal to 261.4 grams per mole. And we also need the mole ratio from the reaction equation. So 1 mole of barium nitrate is equal to 1 mole of barium sulfate. So it's a 1-to-1 ratio, which is going to save us some calculation time. Mass calculations are a 3-step conversion factor process. So I'm going to set up my 3-step template here. So I'm starting with 200 grams of barium nitrate. I'm going to fill this box in with a 1. The first thing I need to do is convert grams of barium nitrate to moles of barium nitrate. That's where the molar mass comes in to play. So grams is on the bottom, moles is on the top. I'm trying to squeeze all these compounds in so that it doesn't get confusing. So at this point, grams cancels, and we've converted to moles. Next, I need to convert to moles of barium sulfate from moles of barium nitrate. That is a 1-to-1 ratio. Now I can cross out moles of barium nitrate. Now I need to convert from moles of barium sulfate to grams of barium sulfate. And to do that, I also need the molar mass of barium sulfate. 1 mole is equal to 233.4 grams. So I didn't write that down before, but that's what you get when you add up 1 barium, 1 sulfur, and 4 oxygens. So now moles cancels out, and I have what I'm looking for, which is grams of barium sulfate. So let's do the math. I'm starting with 200 grams. I'm dividing by the molar mass of the starting material. I do not need to multiply by 1/1. I don't need my calculator for that, and then I just need to multiply by 233.4 grams per mole, and I get 178.6. So I'm rounding up. $178, rounding up the 6, rounding the 5 up to a 6, keeping 4 significant figures because there are 4 significant figures in the starting weight of barium nitrate. So that's one reactant. The next reactant, I'm going to do the same thing. I don't have a lot of room, so I'm not going to write the conversion factors down ahead of time. But they are going to be similar. I need the molar mass of the starting material and the product. I need the mole ratio from the equation between sodium sulfate and barium sulfate. So I'm starting out with 100 grams of sodium sulfate. Just like above, I need to change to moles of sodium sulfate first. So grams is going to be on the bottom because that is going to cancel that way. So grams cancels, I'm left with moles. Then I need to convert moles to moles. So I'm converting to moles of barium sulfate from moles of sodium sulfate. So now moles is going to cancel. And then the last step is identical. So it's grams of barium sulfate over moles of barium sulfate. And now moles of barium sulfate cancels, and I'm left with grams, which is what I'm looking for because it asks how many grams are produced in the question. I need to fill in my numbers. 1 mole of sodium sulfate is equal to 142 grams, so that is the molar mass of sodium sulfate. In my chemical equation above, the coefficient for barium sulfate is a 1. The coefficient for sodium sulfate is a 1. So that's another 1-to-1 ratio, which saves us some calculating. And the last step is the same exact numbers because it's the molar mass of the product that we're interested in. And now I just need to do the math. So I'm starting with 100 grams, dividing by 142. That gives me the moles of sodium sulfate, which is equal to the moles of barium sulfate because it's a 1-to-1 ratio. Now I just need to multiply by the molar mass of the product. And I get 164.4. I'm keeping 4 sig figs and rounding up again like I did in the calculation above. So now I have my two numbers that I need to compare. I'm comparing 178.6 grams to 164.4 grams. The sodium sulfate produces less of the product, so it is the limiting reactant. You will run out of sodium sulfate before you run out of barium nitrate, and the reaction will stop. So the most barium sulfate you can produce is 164.4 grams. So that is the theoretical yield.